Mankind has always dreamed of traveling into space, leaving the Earth, and discovering new horizons. This crazy quest has gradually become a reality. But the dream hasn't stopped there, and to go even further, they built a structure over our heads, 400 kilometers above the planet, the International Space Station. A steel monster some 108 meters long and 73 meters wide. It required the expertise of American, Russian, European, Canadian, and Japanese space agencies to put this incredible scientific laboratory into orbit. Like an enormous construction set, each piece was designed and constructed on Earth before being transported into space. It took 10 years to assemble in a challenge that went way beyond international borders. For almost 20 years now, 200 men and women from different countries have dedicated themselves in turn to live and work on board the International Space Station.
Of course, the station has become our baby. It's our favorite toy, and we never get bored of it. It's our home, our place of work.
Reaching the space station is no simple feat. It involves a long voyage on Russian Soyuz spacecraft. After a 48-hour flight, the Soyuz is within 400 meters of the ISS.
The first thing that you see is a bright dot, like a star, that is showing up somewhere on the display. As you get closer and closer, you see a little bit this dot growing. Then you see the wings, the big solar wings of the space station.
Like explorers discovering a new world, each time they approach the station, even the most experienced astronauts can but marvel at the spectacle.
It's really huge. You've seen it so often in photos, images, or video, but you can't believe that human beings were capable of constructing this huge station in orbit in space.
Then out my window, I could see solar arrays and thermal radiators and pieces of the station that kind of extend out into that corridor that we're traveling in. And they just get closer and closer and closer and fill the view of your window. You actually feel like you're being engulfed by the space station as you're coming in on a Soyuz.
I've been to the station 3 times, and each time my feelings were the same. Admiration. Admiration for the size of it. It's truly gigantic.
It looks wrong. I mean, it looks to your eye, there's something alien about everything you see. You will see any beam or post or module extremely well lit on one side, over bright, kind of, harsh lighting. And then right as you roll around to the side that is not directly facing the sun, it is black.
Range is 3. The roll has stabilized. There is no roll now. There is no roll deviation. We're approaching really nicely.
Есть катание.
Contact confirmed. And probe retraction confirmed.
Docking confirmed. A textbook arrival for the brand new Soyuz MSO-1 spacecraft. Docking confirmed at 11:06 p.m. Central Time.
You're going from this incredibly cramped Soyuz through a hatch system, which is actually even more cramped. Once you open that, you still have the 2 hatches, the ISS hatch and the Soyuz hatch, to get past. So you're actually moving through an even tighter little space, and sort of being pulled in by your crewmates. You're coming through a birthing canal and being aided by the doctors on the other side to pull you across and into the main volume of the space station.
And the hatch now opening.
And when you leave the little ship and enter the huge station, you're overcome with emotion. You discover this huge space. You recognize some faces. It's really moving. Of course, it's overwhelming.
The total volume of the ISS is comparable to that of a 5-room house, and it was designed to be home to 7 astronauts. Each one stays there for an average of 6 months. From their very first moments on board, and despite their years of training, new arrivals are often disconcerted because they have to learn to live in zero gravity, where there is no up or down.
You're in 3 dimensions, and you're using a module that is up there, on the left, on the right, below, in front, behind. It's a bit complicated to get your bearings in the beginning.
Your brain sometimes processes the image completely different because the fluid in your inner ear is sending a completely different message to your brain. You're looking down the tunnel, and it's almost like you're looking up a building. You know what I mean?
I made a right turn into the service module, and then suddenly I stopped because suddenly I couldn't recognize where I was. And I thought to myself, I can't believe I'm already lost on board the International Space Station, especially because I've spent hundreds of hours training in a model of it here on the ground. But luckily, one of the more experienced astronauts could see that I looked a little bit confused, and he told me it's because you're standing on the ceiling. As soon as I flipped over and got my feet back on the floor again, it was as if everything fell into place and I could suddenly recognize where I was.
The astronauts find their way around thanks to a marking system that shows them up and down. The absence of gravity also gives them a 360-degree working environment.
Of course, most of these modules you'll see they have 4 sides, and they're put together. That way we could sort of work on a flat plane, either a wall, a floor, another wall, or the ceiling. But, you know, again, all you have to do is turn yourself and your reference changes.
This almost complete lack of gravity presents its own problems for the human body.
We are not used to function in microgravity, so we have too much blood pressure in our head. The blood shift is happening, so that's why you see astronauts, certainly in the beginning when they fly to space, that they have kind of a swollen head with red puffy face.
The astronauts' faces look a little puffy because their blood flows differently. The blood doesn't flow as well to the lower part of the body and accumulates in the chest and head. The veins around the neck and face swell up. So naturally, the change of blood flow presents some problems.
So you actually feel that inside your head. You feel this increase in intracranial pressure, and it causes some stuffiness in the nose as well, sometimes a bit of a dull headache as well. But, and that can actually last for a few weeks as your body adapts and adjusts to microgravity.
But the ISS is much more than a simple home in orbit around the Earth. Above all, it's a top-flight science laboratory in permanent residence in space. Over the past 2 decades, astronauts have carried out over 1,700 experiments there. Japan, the US, and Europe have each supplied a lab: Kibo, Destiny, and Columbus. The almost total lack of gravity and the almost total vacuum outside the station makes for an environment that is impossible to recreate on Earth. These 2 properties create ideal research conditions and the chance to use some unique chemical and physical processes.
This research can be absolutely fundamental, with essential questions involving the effects of gravity on metabolic modifications, on combustion, on alloys, on fluid mechanics, with issues we can't explore on Earth because we cannot remove the effects of gravity.
The research carried out in this permanent space lab covers multiple fields like biology, material science, observation of the Earth, and astronomy. The results of some experiments already carried out have allowed us to create revolutionary new alloys and new medical treatments. The ISS also means we have a permanent human presence in space and can thus prepare for future manned voyages to other planets.
Not only have certain experiments been useful for key research, but some will help us fly farther, higher, and faster.
The success of the veggie experiment, which involved growing lettuce in orbit, is considered a real advance in terms of long-term space missions. The system was designed to supply a permanent source of fresh food to the crew.
Cheers, cheers, cheers.
On board the space station, they are also carrying out experiments in robotics. In a few years, remote-controlled robots could build other stations or even carry out experiments. This is another stepping stone towards Mars.
But the special thing about this joystick was that I could feel the forces that the robot was exerting. And that's sort of a first step towards developing what we call an exoskeleton arm, which is a robotic arm that you can wear yourself. And as you move your arm, the robot follows your arm movements, but at the same time, it sends back the forces, so you can actually feel and control the forces that the robot is exerting.
In the future, humans will also need to be capable of withstanding very long voyages. As such, the human body is also subjected to experiments on the ISS.
Tube's filling up quite nicely.
We're guinea pigs up there, so we're participating in experiments studying the effects on our bodies in that environment, the weightlessness, radiation, and any other aspects of that unique environment.
The last 10 years have shown that the vision of 75% of astronauts is altered by long stays in space. For a long time, it was believed that the rush of blood to the head was behind these sight issues. But recently, it has been established that the liquid surrounding the brain and the spinal cord can also play a role in these vision problems.
We're still not quite sure of the cause. There are some theories that it's intracranial pressure causing it. Maybe higher CO2 levels that we breathe in the atmosphere might contribute towards this as well. But what seems to be happening is a flattening of the retina. And that flattening of the retina is causing up to about a diopter shift in vision, so becoming nearsighted.
What this shows us is that in the end, human beings have an astonishing capacity to adapt. In a weightless environment, the astronauts' bodies lengthen and can grow between 2 to 7 centimeters in length.
And this is something I find that's remarkable about our human body, is how good it is at adapting to new environments. If we were going to live in space in microgravity permanently, then the human body is brilliant. It would be offloaded, the heart muscle would shrink, our bone density would reduce, our muscle mass would reduce, and we would very quickly become a very good being, a very good body for living in microgravity.
After 6 months in orbit, it's only when they return to Earth that the astronauts truly realize the importance of gravity's pull on their bodies.
It was really shocking. After my first flight, I felt just how heavy my arms were. Really, really heavy. I could also feel my guts. I really could. I don't know how to explain it to you, but I could feel the organs inside me. And I can tell you, they're really heavy.
The idea of establishing a manned space station in orbit around the Earth is not a new one. In the 1920s, the Russian Konstantin Tsiolkovsky, the undisputed grandfather of astronautics, imagined a space station where men could live. In 1971, the Russians sent the first space station into orbit, named Salyut-1. The Americans responded 2 years later with Skylab. Then, in the middle of the Cold War, in 1975, the Russians and Americans proved that space cooperation was possible with a joint Apollo-Soyuz mission.
After Apollo-Soyuz, there was a pause in the manned spaceflight programs in both the USSR and the USA.
In the mid-1980s, space cooperation was no longer. The Americans had the shuttle, and the Soviets were dominating manned spaceflight with the Mir station. The USA was planning to build its own station, but given the mammoth size of the task and the cost involved, the Europeans, Canadians, and Japanese came on board. With the collapse of the Soviet bloc, Russia was also invited to join the adventure, and the result was the ISS. Everyone involved committed to sharing their knowledge and supplying part of the station. The construction process was simple. 15 modules would be built on Earth and then assembled in space.
In fact, the space station is the biggest plug-and-play that has ever been made.
The scope of the project was immense.
Today, we still talk about the pyramids with admiration. And the ISS is the same. In the future, we'll talk about the ISS like we talk about the pyramids.
The space builders entered the frame in 1998, when the first American module was anchored to the first Russian one. Over the space of 2 years, more and more missions set off to build the station and prepare for the arrival of its first permanent residents. On November 2, 2000, cosmonaut Sergei Krikalev officially became the first resident of the International Space Station.
The first thing we had to do was to turn the lights on. We had to establish the link with Earth, and I had to find a cable hidden behind a panel. And then we could do the first report. Yes, the first thing we had to do was turn the lights on. After that, we plugged in the service module systems. We started the unit for creating air, for purifying the carbon dioxide, and ventilating with oxygen. They were critical moments. If we hadn't been able to get that going, we wouldn't have been able to stay on the station for long because the reserves in the Soyuz vessel were very low.
Building the station took 115 launches to bring the modules and teams into space. Canada provided a key element in the shape of a robotic arm. 17 meters long, it is used to move modules, supplies, material, and even astronauts. The fruit of international cooperation, the ISS gradually took shape in the sky.
We designed every mission so that if something didn't work, we would put it back into the shuttle and we'd bring it back home, but we never had to do that. Everything worked up there, and it was amazing.
Especially when you consider that many components of the space station never were tested together on the Earth and integrated only on paper.
Of course, it was all theoretical, and I was pretty surprised to see that we got it fully deployed. It's an absolutely extraordinary example of technological prowess.
The construction and operation of the International Space Station is the most expensive project ever undertaken by humankind, costing some $150 billion.
Firstly, it's not a huge amount of money, and what we're getting in return is a vast amount of scientific knowledge and understanding that is benefiting people back here on Earth. And if nothing else, it's an incredibly valuable insurance policy for the future.